When you think of honeybees, yeah, you probably think of honey. But their biggest job isn't actually making a sweetener for your tea, it's pollinating the very crops that end up on our dinner tables. So let's dive into this, because figuring out how to keep these tiny workers healthy, well, that has huge implications for all of us. I mean, these little guys are one of the most economically significant insects on the entire planet. Their role as pollinators is absolutely crucial for agriculture. That means the health of their colonies is directly tied to the health of our food supply and even our economy. So helping them out isn't just a nice thing to do, it's essential. And this is where modern science comes in with this really cool idea called precision beekeeping. Just think of it like a high-tech health tracker, but for an entire beehive. It's all about monitoring individual colonies in real time to give them exactly what they need right when they need it to boost their health and their productivity. All right, so using this precision approach, we can start to tackle some of the biggest threats to bee colonies. And one of the most fundamental challenges they face is temperature. A hive has to maintain this perfect internal climate, right? But what happens when the weather outside gets way too hot or way too cold? For them, it is a constant battle, and that really gets to the heart of what we're talking about today. So let's look at this fascinating study that tried to figure this all out in the simplest way imaginable. Researchers in Egypt wanted to know, what's actually better for a beehive, sun or shade? It sounds so basic, right? But believe me, the answer can literally make or break a colony's entire year. So here's what they did. They set up a perfectly controlled experiment. They took 12 bee colonies, all basically identical. 6 of them were placed in a nice shaded area, and the other 6 right out in the open sun. Everything else was kept exactly the same. Then they just had to watch and see which group would thrive. But as the data started rolling in, it became clear that the answer wasn't so simple. It wasn't just sun is good or shade is good. In fact, the most crucial finding was that the best place for a hive completely flips depending on the season. What helps the bees in the winter actually hurts them in the summer. Okay, so check this out. During the cooler months, this dashed line here represents the colonies sitting out in the sun. As you can see, they consistently had way more forager bees out collecting food. That sunlight was basically giving them a free energy boost to get warmed up and get to work. And all that extra food, well, it paid off big time. This graph shows the amount of worker brood, which is essentially the nursery for new bees. And again, the unshaded colonies basking in the sun's warmth were able to raise way more youngins, building a much stronger and larger workforce. But then, summer arrives. And this is where it gets really dramatic. You can see it right there on the graph. The lines cross. It's a total reversal. All of a sudden, that intense heat becomes too much for the sun-exposed hives, and their populations start to dip. Meanwhile, the shaded colonies, protected from the heat, now they're the ones that are thriving. Their populations just surge ahead. And of course, this all leads to the bottom line, honey. During the cooler clover season, the hives in the sun produced a staggering 26% more honey. But during the hot cotton season, the shaded hives completely took the lead, producing 19% more honey. The difference is just stark, and it's all down to a little bit of shade. So what is actually going on inside these hives that causes such a massive shift? Why is temperature so incredibly critical? The best way to think about it is that a beehive acts like a single superorganism. All the bees work together as one, and one of their most important jobs is to act as a living, breathing thermostat, regulating the hive's internal temperature with amazing precision. And they are aiming for a very specific number. The brood, that's the developing baby bees, needs to be kept at a stable 35 degrees Celsius or 95 degrees Fahrenheit. Any big swing from that can disrupt their development and weaken the whole colony. And get this, their ability to do this is just astonishing. A single worker bee can detect a temperature change as small as 1/4 degree Celsius with its antennae. That level of sensitivity is the key to their entire climate control system. So here's the problem in the summer for those hives in the sun. It just gets too hot. The bees have to stop what they're doing, foraging, raising the young, and switch to emergency air conditioning duty. They start fanning their wings and using water evaporation to cool things down. All that energy spent on cooling is energy that's not being spent on making honey or growing the colony. And on the flip side, here's the problem for the shaded hives in the cooler months. Without the sun's help, the hive gets too cold, so the bees have to divert energy to generating heat, vibrating their muscles, and burning through their precious honey stores just to stay warm. And again, that's energy that can't be used for foraging or raising the next generation. So when you put all this data together, the takeaway is incredibly clear and really powerful. For beekeepers, the strategy is pretty simple. In the summer, give your hives some shade to save them the energy of cooling. But in the cooler months, take that shade away and let the sun provide some free, natural heating. It's a dynamic approach that works with the seasons, not against them. And that's the real beauty of this whole thing. It shows that precision beekeeping isn't always about expensive gadgets. It's about having precise knowledge. We used careful observation to find a solution that's just elegantly simple. It's about understanding the natural rhythms of the colony and working with them. And it really makes you wonder, doesn't it? By just carefully observing and understanding the world around us, what other simple, powerful solutions to big problems are out there, hiding in plain sight, just waiting to be discovered?